Now we can see in fourth unit normal form of context-free language. Which context-free language is called as normal form means the first the context-free grammar should be in the normal form. When the context-free grammar will be in normal form means it should not have useless symbols or productions. So we have to eliminate the useless symbols or productions from the context-free grammar. If you use this normal form context-free grammar means the resulting language will be normal form context-free language. We can see the three things which we have to eliminate from the context-free grammar. The first is we have to eliminate useless symbols. Next we have to eliminate epsilon productions. Next we have to eliminate unit productions. If you eliminate all these things means the context-free grammar will be in the normal form context-free grammar. Okay, we can see how to eliminate the useless symbols. There are two stages for to eliminate this. Stage 1, we have to obtain the set of variables and productions which derive only string of terminals. If you have a non-terminal means it should derive only the terminal. If it is not deriving a terminal then that is not a valid one. This is stage 1. Next in stage 2 we have to obtain the set of variables and the terminals which are reachable from the start symbol. We have to the terminal or non-terminal should be derived from the or reached from the start symbol. Okay, the two stages. If the two stages are not applicable means then that variable is a useless symbol. So therefore, how should the production should be means from the start symbol. If we consider this x should be reachable from the x, that is start symbol, and it should derive a string. Then it is x is a useful. Otherwise, x is a useless symbol. Then we have to eliminate such type of symbols. You can see the example for eliminating the useless symbols in a given grammar. We have already seen the general procedure in two stages, stage 1 and stage 2. Now we can see the example by applying that algorithm. This is the given grammar. Okay, here we have to obtain the CFL in a normal form, that is without any useless symbols. Okay, this is the given grammar. First we have to apply this stage 1 to this, that is obtain a set of variables from which we get only string of terminals. In this productions we have to consider only the variables which derive the terminals only. Okay, if you consider here we can take A, B, E because B is not having only one terminal. A is having A, small a, D is having small a, B, E is having D. So we are considering these three and we are deriving them. That is A, D, B, E, or that is old variable, this is new variable, O, V, N, D. Okay, the old variable is 5 at starting. Then we are considering A, D, E. Here, then A is already I have told this is deriving only terminal A. D is deriving A, B, E is deriving D. Again, we are considering this as old variable. Now we can consider the S because we are having terminal and non-terminal. If you consider this case, the four things will be coming A, D, E, S. Here we are having these. Why we didn't include B here means we are not having the B, the terminal and non-terminal. So we are not considering that. So here if you apply again this, we are not retrieving any more. So these are the two things. From this we can come to the conclusion. The variables are A, D, E, S. Okay. The terminals are A, B and D. So based on these variables and terminals we can have the productions capital A, capital D, capital E and capital S. Okay, from considering this as the input to the second stage, we have to obtain the symbol X that is reachable from the start symbol S. Which are all reachable to capital S, we are going to consider that. First we have to write the productions, then terminals, then variables. For the first thing we are having the variable capital S. Then we have the particular production means small a, capital A, already we have seen here. In this terminal is A and the variables are capital S and A. Again, if you consider the A means you will be having A, the small, the terminal is A. Again, the variables are S and A. So therefore, from the stage 1 and stage 2, the resulting grammar is the variable is capital S and capital A. The terminals is A. The productions are S tends to A tends to AA. As the S is reachable to A, we can write in the production of A also. So S is the start symbol. Eliminating epsilon productions. Production of the form A tends to epsilon is unreachable in a context-free grammar. But it may start symbol. Okay, such epsilon productions can be removed like this. Okay, here we can see an example for this. Here the start symbol, from this it is derived at non-terminals and terminals. From each and every non-terminal, the terminals, non-terminals and epsilon is also derived. In case of epsilon, they should be eliminated. How we can eliminate? In two steps we can eliminate. Step 1, we have to find the nullable variables first. Here if we consider the old variable, new variable productions, first the old variable is 5, then we are considering BC as the productions having deriving epsilon. So based on this, we are again applying as BC as old variable. From this we are deriving A as new variable, as in the case the A is deriving BC. Okay, so if we include A also, now A will also become as nullable variable. So therefore A, B, C are nullable variables. For these nullable variables, how we can replace the productions we can see now. Here we are going to construct a new productions by replacing this epsilon. Okay, first we are taking all the productions this side and inserting productions this side. As A, B, C are nullable variables, we have to separate each and everything in this case. So if we separate this, we are already having A, B, C, A. Again we eliminate, that is A is replaced by epsilon. When it is replaced by epsilon, we get BC. When B is replaced by epsilon, we get AC. When C is replaced by epsilon, we get AB. Then if we replace AB epsilon, we get CA. If we replace CA, A and C, we get BA. If we replace BC with epsilon, we will get CA. So we have to replace each and everything with the epsilon, which are nullable variables that has to be replaced by the epsilon. The resulting production will be on the right hand side. If you consider S tends to BD, here no nullable variables, the similar will be there. If we consider A tends to BC, here B and C are epsilon productions. So we have to consider each time B replaced by epsilon and C replaced by epsilon. Then we are having B tends to this, we are removing the epsilon in B and C. Then afterwards capital D, that is deriving only small, so it is will be similar. This is the resulting. The variables are, that is terminals in this productions are A, small a, B, C and small d. The variables are S, capital A, B, C and capital D. You can see how to eliminate unit productions. First you can see what is unit production. If the left hand side and right hand side we are having only one non-terminal, then it is known as unit productions. This can be eliminated as follows. First we can see how to remove all the productions of the form A tends to A and all non-unit productions to P1. That is, we are going to eliminate the unit productions and we are going to consider only the non-unit productions. For each variable A, find all the variables B. Then we have to find a dependency graph. Based on that graph, we will derive what are the non-terminals is required and what are the things is not required. Finally, all the unit productions can be derived from the grammar. We can see an example here. The resulting grammar will be the original grammar. There won't be any meaning change in the grammar. Okay. Now we can see an example here. The thing is that from the start symbol, the A 0 and B is derived. Again B is derived A 1 1. A from A 0 1 to B are derived. The terminals here, if you consider from start symbol 0, from B 1 1, from A 0 1 2 are derived. These are the terminals. Okay. Now the unit productions here are S tends to B, B tends to A, again A tends to B. There is a cycle and also dependency in this graph. We have to remove these unit productions. The non-unit productions, if you consider that, means S tends to A 0, then B tends to 1 1 and A tends to 0 or 1 2. All are terminals. Okay. Now we can see the dependency graph, that is S tends to B, here B tends to A, again A tends to B. So what are the productions generated by B can also generated by A. So by considering this, we can introduce new productions. Here the S tends to A 0, the A is replaced by what are the terminals of the B and A? 0, 1 to 1 1. So it will be replaced by A. Okay, so we are having, instead of A, we will be having 1 1 0 1 2. The terminal of B is 1 1, it is already 1 1 0 1 2, and A tends to, instead of B we will be having 0 1 2 1 1. Here it will be all the terminals of the A 1 1 0 1 2. Now we can see how to convert the given grammar into GNF. To convert the given grammar into GNF, there are 4 steps we have to do. First we have to eliminate all epsilon productions, then we have to eliminate all unit productions, then we have to convert the given grammar into CNF after eliminating all this. Then finally we have to convert the grammar into the GNF. So if we see here, there is no epsilon productions, so no need of doing the first step. The second step is we have to eliminate the unit production. There is one unit production, that is A tends to B, again B tends to A here. We have to eliminate this unit production. How we are going to eliminate means we are going to replace this B by 1A1. So after substituting this, we will get the grammar in this format. S tends to AB1 or 0, A tends to 0 0 A. Instead of B we have replaced 1A1 and B again 1A1. The second step is over. Third, what we have to do, we have to convert the grammar into the CNF. How the grammar is converted into CNF means in 2 steps. First we have to replace all the things, that is terminals with the non-terminal. Then we have to restrict the right hand side of the productions with only 2 things. Okay. First we are seeing here, this grammar is converted into, in this format, as there is terminals in this side. These terminals are replaced by the non-terminals. These terminals are replaced by the non-terminals. So 1 is replaced by A1, 0 is replaced by A0. If we do this, we will get this grammar. If you see here, there are more than 2. So we have to restrict the right hand side of the production, that is, there should be only 2 non-terminals. So if we restrict like this, it will be coming like this. S tends to, all the things is replaced by D1, D2, D3. So BA1 is replaced by D1, A0 A is replaced by D2, and AA1 is replaced by D3. If we substitute here, we will get S tends to AD1 or 0, A tends to A0, D2 or A1, D3. Instead of 3, we will get all the things in the 2 format. Okay, after this, what are I going to do? I am going to substitute each non-terminal with the A1 to A8 to convert the CNF into the GNF. Okay, up to this, the grammar is in the format of CNF. Now we want to convert the CNF into GNF. For that purpose, we are replacing all the non-terminals with the A1 to A8. S is replaced by A1, A is replaced by A2, B is replaced by A3, A1 is replaced by A4, A0, A5, D1, A6, D2, A7 and D3, A8. Now we can see how we are going to convert the CNF into GNF here. Now we are getting, after substituting that, here we will get this grammar up to A8. Now what we have to do, we have to replace the things with the, here if you see A5 and A4 is 1 0. We have to substitute this A5 and A4 in each and every production. First we substitute this in the A3. Then we will get A, instead of A5 we will replace with 1. We will get, see here, A3 1 8. Okay. After